Our final speaker is Dr. Stephen Carr from the University of South Wales. He's a research fellow in the university. He has received his Master's in Physics degree in Physics from the University of Oxford in 2004 and his PhD in Energy Systems Modelling from the University of Glamorgan in 2010. He has worked on the UK Sustainable Hydrogen Energy Consortium, SuperGen project funded by WPSRC, investigating the optimal use of hydrogen energy storage on electricity networks. He has recently worked on the Crimea H2 Wales project, investigating renewable hydrogen systems, and the Innovate UK funded Island Hydrogen project, investigating optimal operation of hydrogen refueling systems for vehicles. His current research includes electricity systems modelling, energy storage, and hydrogen energy systems. Stephen, over to you. Thank you.
Hi, Bob. Thanks for the introduction. So today I'm going to be talking about industry, so industrial carbon emissions, where hydrogen could play a role in that, some of the work we're doing at the University of South Wales in that area, and then finally about industrial clustering and how that looks like it could help with the idea of hydrogen highways. So just to set the context, this is from the Committee on Climate Change, looking at last year, 2019, and industrial emissions account for 21% of the UK's total carbon emissions. And that's the second largest sector now in the UK. So it's a major sector and it's a major area. And if you look at 2050, looking at zero carbon, that has to be nearly all gone by then, which is a major challenge. So within the industrial sector in the UK, there were about 320 terawatt hours of fuel being consumed within industry. Some of that is from energy from things like electricity, where it makes sense to decarbonise electricity, but about 89 terawatt hours is currently used with fossil fuels, things like natural gas, and there's a potential there to look at fuel switching for decarbonisation. And one of the major fuels which could be used in fuel switching is hydrogen, is low carbon hydrogen. It will have to compete against things like further electrification and biomass, but it has the potential to play a large role and provide a large amount of energy within industry. Those 89 terawatt hours, which have been identified, this is a study from Element Energy and Jacobs Industrial Fuel Switching from 2019. They identified really indirect heating and direct heating processes suitable for fuel switching, which are currently mainly fired by natural gas and coal. And within direct heating, one of the areas is reduction, particularly of iron ore, which uses a huge amount of energy and is currently mainly done by coal and has a big area for decarbonisation. So at the University of South Wales, we're based in the South Wales area, and within Wales, there are a smallish number of major carbon dioxide emitters within industry. So this figure on the left is from the CCC, Building a Low Carbon Economy in Wales. And we have oil refineries, we have cement works, we have liquefied natural gas emissions, but 50% of Welsh industrial emissions come from the Port Talbot Steelworks, and that represents 16% of all carbon emissions within Wales. So it's a major emitter, and looking down to 2040, we need to look at how we can decarbonise that. Globally, iron and steel themselves account for 30% of industrial emissions and 77% of total global CO2 emissions. So these are major areas and major sectors which need decarbonisation. And you can see within Wales, lots of emissions from the power sector and lots of emissions from industry. They're the major sectors in the UK. In Wales, in the UK, it's transport, but within Wales itself, it's power and industry are the major emitters. So looking ahead to zero carbon by 2050, we're going to have to look at fuel switching, but we have existing processes which are currently emitting large amounts of carbon dioxide. So we need to look at how we can decarbonise them in the nearer term future. So this is some work that we at the University of South Wales are doing with Tata Steel. It's being led through a KES PhD studentship, Sjoerd van Aert, and funded also through the Reducing Industrial Carbon Emissions project, which is an ERDF funded project. And it's looking at coke oven gas and how we can get hydrogen from within that. So 75% of steel produced globally is via the blast furnace, basic oxygen furnace pathway. That's a major way we produce steel. And the first step of that is to produce coke from coal for the reduction of iron ore. So it uses coal and large amounts of CO2 emitted because of that. A byproduct of that process of making coke from coal is coke oven gas, which has a large energy content, 18% of the original coal energy content, and also coke oven gas has a very high hydrogen content. About 60% of coke oven gas is hydrogen. Globally, about 50% of that cog is used on site for its thermal value on the steel works, but the remainder is flared or vented. So it goes to the atmosphere and that energy is lost and CO2 is released. But within the steel works like Tata, which is more integrated, less of that is flared. It's used on site thermally, but there's still potential to upgrade that cog to get the hydrogen out of that and to make a high value hydrogen project from the cog. So this is work we're doing as part of this, which is a combined pressure swing absorption system and an electrochemical hydrogen purification and compression system, where there's the potential to upvalue that cog to extract a very high purity, high pressure fuel cell grade hydrogen from it. So we're investigating that. So this is two parts of this project. One is developing a test rig to test this process in the real world. It's a 2-bed pressure swing absorption test rig, which we are building and installing at the University of South Wales Bagman Hydrogen Centre, combined with an electrochemical hydrogen purification and compression unit. That's underway, but as well as this, Sure, the student looking at this is looking at Aspen absorption software and modelling the process and finding that there's potential here to produce high purity hydrogen from this. He's looking at the best way to operate the system. One thing we see is that the membrane itself is poisoned by CO, and that can limit the performance of the pressure swing absorption system itself. So we're looking at things like CO selective absorbents in the PSA system, different ways of operating the system, different pressures to maximize the purity and recovery rate overall, and that is ongoing work. So another thing we're doing, similarly with Tata Steel and funded through KES and RICE, this is being carried out by another PhD student funded through the KES2 system, Michael Chekhar, and led by Christian Laycock, who is at Fuel Cells Lead at the university. This is looking at upgrading coke oven gas, using solid oxide fuel cell technology. And it's looking at cog mixtures and can you get as much hydrogen into that as possible so you can then later on generate this high purity hydrogen project. So solid oxide fuel cells operate at high temperature, and we're looking at hydrogen amplification of the cog gas. Some of that comes from thermal reforming, catalytic conversion of the CH4 to hydrogen with steam under high temperatures, and some of it comes from the electrolytic conversion of steam to hydrogen. So this is experimental work being done at a bench scale. So this is, again, recently published work, looking at different fuel mixtures, different types of fuel mixtures to put in, different levels of hydrogen and methane in there, looking at how much amplification comes from the reforming route, how much from the electrolysis route, and then looking at, well, this is a lab scale, what would this mean on a larger scale, looking at energy balances and overall efficiency. So that's some of the work we're doing. And finally, I just wanted to talk about what this means in Wales for the industrial clustering. So within the UK, there's been the idea of looking at areas where there are large amounts of industry and large amounts of CO2 being emitted, and can you form clusters within these regions to help decarbonise industry within these regions. So as part of that, the South Wales Industrial Cluster has been formed. So that's been driven by industry within the region, Tata Steel being a big emitter, has had a large part of that. Other companies such as Costain and CR Plus driving that forwards. And the idea is to look at industrial clustering to help achieve decarbonisation. And hydrogen is a key part of that vision. So by no means is it certain to play how much a role it will play, but it has the potential to play a role. So this is a map of South Wales with a hydrogen pipeline and a carbon pipeline going through it. So that we have potential sources of hydrogen production from renewables, from industrial processes, from fossil fuel reform with CO2 capture. We have industry which can use that hydrogen, but no sectors are separate. Sectors are integrated, transport sectors, electricity sectors, heating sectors, industrial sectors, and potentially through clustering, you can start to develop hydrogen infrastructure and help to develop the idea of this hydrogen pathway coming through South Wales, as a potential path to a hydrogen pathway. So that's the end of my slides. So just this is a picture of where we are based in South Wales, near to Port Talbot. This is our Hydrogen Research and Development Demonstration Centre. We refuel hydrogen cars here. We look at projects which I've shown. So thanks for listening, and happy to answer any questions.
Stephen, thank you very much indeed for a great presentation. And a quick question, get you out of the blocks. How important is the likes of greening the steel industry in South Wales to jobs, security and industrial growth?
Well, the steel industry in South Wales, especially in the Port Talbot area, is a major employer, and it would be a very bad thing if it went. So, and it has to decarbonise. It can't keep on producing carbon dioxide emissions as it is. So it has to be green somehow. How that is done is unsure at the moment. There are things like hydrogen direct reduction, looking further ahead, which can be investigated. Capturing the carbon produced from the blast furnace process, but somehow it has to be done.
In order to keep the jobs and to move forward. And how important that is then to the Welsh economy?
It's hugely important, I think, for the Welsh economy overall. So it's not just the people that Tata employs directly, but the indirect jobs, people working there on site, contractors, and how that money spreads out into the economy. So I think it's majorly important. And
on your hydrogen highway, how far or how close to market are the offshore wind producers then to feed into that Welsh grid or that Welsh hydrogen grid?
So offshore, I think at the moment people are looking further and further offshore, and the potential to generate hydrogen offshore and bring it in a pipeline onshore to onshore to be used. So there's big wind farms in North Wales, but I think we'll see wind being developed further offshore and potentially being converted to hydrogen offshore and piped in.
And a final question from Kyle. Kyle Fanning wants to know a bit more detail about the South Wales Industrial Cluster.
So this was formed, I think it was last year or the year before. So within the UK, there's been identification of a number of sites, such as Teesside, Liverpool, where there's major industry, and the idea that clustering together can help to see how you can look at holistically and decarbonise, the best way to decarbonise the whole cluster in itself. So South Wales is a bit different because it spreads along the whole of the South Wales region. So it's quite a diverse and dispersed cluster, but it also has these major emitters like Tata, like Milford Haven. So there's a website for the South Wales Industrial Cluster, which is worth having a look at. At the moment, there's been a roadmap being developed of how to decarbonise, and that's in the process of being developed. And I think you'll be seeing more of that in the nearest future.